Hi, welcome to another M5 Altium tutorial. So we're going to do something a little different with this particular video and series. We are going to kind of do this podcast style format where right now it's Jay and I.
Hey
Say hi.
everyone.
And we are going to do an entire project start to finish, and we're not going to edit it too much. It's pretty much just going to be a chance for you to hang out with us and while we design a PCB and we show the entire process. So before we get into it, what we have right now is kind of some brainstorming that we've done. So we're going to be creating a watch, or a PCB for a watch, and we've picked out the main components. So we have a screen here, we have our MCU, we have some important connectors like our USB-C, and plenty of other things that have to do with batteries, real-time clock. And then there's some optional things like an accelerometer or a battery management IC. So these are all things that you should be thinking about before you get into your design. And we've also picked parts that we know exist in the manufacturer part search. Um, that's not a requirement. Obviously, you could make your own footprints if you needed to, but it is going to save you a lot of time if you can kind of look through that manufacturer part search and see if they're there ahead of time.
And additionally, not only did we choose parts that we know are in the part search, we chose parts that we know have software support. So that there's already libraries written for them in both Arduino and CircuitPython. So whatever we want to run, we can.
Absolutely. So I think we are ready to hop into Altium and start a new project. So I'm doing this all in the same project group right now. Let's add new project. And let's call it the, I don't know, what do we call it? Let's call it the M5 Altium watch tutorial. And I want to make sure I'm saving this in the correct file path. So let me
What is the
go.
correct file path?
Well,
Like,
that depends where you want to put it. So a lot of people are probably going to be uh, doing this with GitHub. So you're going to want to find your GitHub folder, which is going to be in a different tutorial. Hopefully that's already uh, been watched by the viewer. I am going to just throw it right into the other projects that I have for M5. So let me throw it right in here. And I'll hit create. And then my computer is a little bit old, so I'm going to have to wait for that to load. So maybe we can talk about the big ideas of this project.
so um, we wanted to do this project to give a bit of a view into how some people work when they're designing boards. So this is kind of if we want to make this thing, what are steps we can take to go from no thing to having something, or having a design that we can then order. So as Chris said, we did some brainstorming earlier, and that's just because it's a pretty tedious process. But we said, what do we want to have in this watch? And then we went out and found chips to fit that. So we knew we didn't want to have to implement the screen from scratch. From experience, that's a big task, especially since we chose an OLED screen. And additionally, we knew that we would need certain components. So if you have a microcontroller, where you're going to need a regulator, battery connector, because it's a watch. And crucially, it's a watch. We need something to keep time. So we went and selected a chip that is uh, easy to use. It's on the pricey side, but it's a single package and it's very easy to integrate into design, as well
Yeah,
as being relatively small.
I would say that it's generally worth it to spend an extra buck or two if it means it's going to save you hours of time when it comes to coding or designing the PCB around it. So let me show real quick. Here's the screen that we're going with for our watch. This will probably be the biggest component, and we'll decide the size of our enclosure, which are all considerations we're going to get to later. But there's not too much
And
to it.
that might not be on this specific stream. We could just start with a schematic, probably.
Yeah, absolutely. And so when we design, we're going to have to design the part for this. This is not in the manufacturer part search, I believe. And we're just going to use these headers, correct?
We could either use the headers, which will actually be a faster connection and the screen will refresh quicker, or we could do what they're doing on there and just use the I squared C connection. Um, oh, yeah. Um, Although it looks like, can you go to the fourth photo, please? See how the connectors go right up against the edge?
Which one? These ones? Or oh, these ones.
Sorry,
These
the
ones right here.
stemma connectors,
Yeah,
the
yeah,
little, yeah,
yep.
JST 1P somethings. Um, that means if we're going to use them, we're going to have a little cable bending out. So
Right.
pins.
Yeah, I think we should use the pins, and it'll be easier to design that PCB anyways. We are going to need to know the exact dimensions of these mounting holes because we want our PCB to bolt basically onto the back of this one with some mechanical, clearance in between the two. So we'll get to that too,
Luckily,
how to place those.
luckily, all of Adafruit's designs are open source, and we should be able to just download the Eagle file and view it. Often
Yeah,
they have dimensions on there.
yeah, that's a great thing to keep in mind if you're going to use parts or if gotten permission to use parts from SparkFun or Adafruit. Is don't forget you have access to these schematics, the board layouts. A lot of the times you get the mechanical design or dimensions, so don't forget about those. Cool. All right, I think we should jump in. So I'll save this one for later since we're gonna make a quick part for that. Should be a piece of cake,
Yep.
and we'll
For
start.
now, we can just put some header in there, and we'll just swap the component out later.
Why did we write? Oh, okay. I remember what this
Yeah.
was. Sorry, we went
Um,
through this last week, so I gotta remember.
so for anyone who's curious about what Chris was asking, we need to make sure that we can program the chip we put on there, since we're going to be buying one fresh from the DigiKey or the factory. So we just need to make sure that we account for anything we'll need to do in the setup process. Um, shall we start with just the bare chip?
Yeah,
Build out from there? Okay.
let's
I
do it.
will pull up my reference schematic from my other projects.
So I will
Uh,
search this at SAMD51J20. Let's see what packages we have access to here.
Ideally, we'll go with a QFP. If not, we should go with a TQFP.
Yep, it
Um,
looks like we have a TQFP with a model.
awesome.
This is the one we want,
And
right?
we want the SMD J20. This because it has a lot more RAM and flash than the J19.
At SAMD51J20A-AU.
Perfect.
Cool. All right, I'll right click in place. So we'll put that here for now. Eventually we're gonna have to go through and organize the sheet, but I usually put down my main components first. All right, what's next? USBC connector?
Well, we have not selected that. Let's check the MPS, and then I'll open DigiKey, and we can check what's available.
Yeah, so there's looks like there's going to be a couple main options. There's this longer one, like from Word, and then there's this Molex one, which we talked about
Um,
briefly if you wanted to use the Molex.
yeah, let's use the Molex. If we can get a look at the back of it, that'd be ideal, in case we end up needing to hand solder it. But if not, that's fine.
Let me
What's the
place
part
it.
number?
Can you see it on the screen, or I'll tell you?
It's a little too small for me to see from here. Please speak it to me.
WM, I believe this is the yeah, WM
Yeah.
12856 CT dash ND.
Well, oh, it's the DigiKey part number.
Yeah,
Um,
that's the DigiKey part number.
okay. And just should I share my screen or nah?
Sure, you can share your screen. Let me try and put it onto our recording. Should I put it onto our recording?
Yeah, or not?
Okay,
Okay.
let me throw this in here.
Tell me when you're ready.
I'm ready.
Okay, so here we're on DigiKey. Um, let's take a look at the 3D view, and then we're also going to check the data sheet because idiot checks are always good. Let's see. Oh, my internet's being slow now that I'm streaming.
Wonder if I stop
Here we
my
go.
stream, it'll help.
Okay. Okay. So here's what I was looking for. See how this is the front of the connector, the
Yep,
one with the port. That's where the cable goes in. Near the back, these pins are going to be what does the electrical connection. Um, so USBC is 24 pins, but technically, electrically, you only need 12 if your cable is made correctly. So if for some reason we're unable to airflow, we can hot air reflow. We can always hand solder these because it has pins sticking out. It also means we can probe those pins if we need to.
nice.
And
So I think this one's a good
that
choice
should
then.
be all. Agreed. Also, Molex is a very reputable brand. Shall we switch back to your screen?
Sure thing. All right. How did the stream go? Okay. Where was I? Oh, let me share my screen so you can see.
Thank you.
All right. Cool. So we've got our connector. What's next on our list? We said power source transition MOSFET.
Yes. So actually, this is a bit of circuitry I found while browsing Adafruit. Surprise, surprise. Um, can you switch back to my screen, please?
Oh, yep. Are
Okay,
you sharing? I
I
can see now.
am.
Okay.
Okay. So this is the schematic for the Adafruit Feather M4. And what I'm referring to is right here. Can you see my mouse?
I cannot see your mouse now.
Okay, so in the leftmost of the power and filtering section, we have a MBR120 diode, and then above that, a DMG341 MOSFET. So this little circuit makes sure that when when USB is plugged in, power defaults to coming from the 5 volts in the USB. But when it's unplugged, power comes from the battery. And it does it in a very clever way where you have little to no resistance when you want power from the battery, but you have less resistance from the diode when the bus is plugged in. So I suggest we use this circuit, and I see no reason why we can't use this MOSFET. It's pretty small.
Sure. That's Q3, right? I'm pointing at the right thing.
Yeah, yeah.
Cool. Okay. Yeah, that sounds like a good idea.
And the trick is that there's a pull down on the VBus line.
Cool. So
Okay.
what was the name of that? What was the name of Q3?
It's a DMG341. It's a little slot 23.5 component.
There it is.
Coolio. And the diode, tell me when you're ready.
One moment. Let me place that down. Okay, the diode.
Is an MBR120.
I think that's it.
Yeah, we also need a resistor as well. But
Do you know the value?
yes. So Adafruit says 100K, but from experience, we should go with like 2.7 or 5K.
2.7 or 5K. We'll go with a 5K. Why not? And then
And I will.
let's think about what size we want to choose for that resistor.
It's a pull down, so it's not going to be drawing a lot of power, but it will be burning off 5 volts when it's plugged in. Um,
0603.
I yeah, I went with an 0402 on my personal project. It was fine, but we should go with a 603. We can always make it smaller if we need to.
I think I need to add some more words to this. So resistor, 5K, 0603. Wow, not
You
a
can
lot of
also try
options.
chip res 0603.
So one thing I can do, and we're going to get a ton of hits for that. So if I go into my filter here, don't forget this exists. I can filter now by value. So I could come in here and say there's a 2K, 4.7.
4.7.
I can also specify it if I want, but I think 4.7 would probably work for this, yeah?
Yeah. And worse comes to worse, it's a resistor, and you can always change it on the fly.
Of course.
Fun fact, that's how I learned you needed to use a lower resistance.
Cool. All right, so I'll group these three things together so we know that was from
Mm-hmm.
that part of this. This
Is
is
that
a,
yellow block a diode?
yeah, it actually is.
Oh, that's odd.
Interesting
Yeah.
schematic symbol, but at least it labels pretty clearly. No confusion over which is the anode and cathode.
Okay, cool.
So next we want
Um,
a 3.3 volt linear regulator. There are tons of these.
yeah. So if we were making a real watch, we'd go with a switching regulator, but because this is, casual, we'll just go with a linear one. It's easy and it's cheap, and more importantly, it's small.
Here's one IC regulator linear 3.3
Might
volt 1 amp.
might I suggest an AP2112? They're
Okay.
cheap.
8P2112.
Mm-hmm.
That is not in the MPS.
It's not interesting. Okay. Let me check mine.
8P2112, right?
Uh, yes. Yes, it's on DigiKey. Um,
Try the DigiKey part number.
wait, 8 or A?
8.
A, the letter.
Oh, A.
Alpha.
AP2112.
Yeah.
Ah, that was it. Yep.
Okay, cool.
Looks good. Let's place
3.3,
that.
and I'll see what value capacitor it needs.
So as we're putting these parts down and kind of like blocking out sections, we are going to try and keep that supporting passives. You know, each IC is going to have some supporting, passive components. We're going to try and keep them close together so that we know, like I did down here, which goes to who. So we find that capacitor, we'll put it right next to this.
So we need two, one for VIN, one for VOUT.
Yep.
One one mic each. One microfarad each. And I don't know if you can make comments in Altium, but if we can, let's just make a note that enable is active high.
You can.
Okay.
And I will do that by grabbing this so that it's floating, hitting tab. Then I will get to see the properties if my panel doesn't freeze. And then I can make comments, I can add to the description. So I'll change this comment. Actually, I won't because that is some helpful information, but I will add it to the description. There's other ways to do this too. You can also add text to the sheet. Maybe that's better. What do you think? Maybe that's better because we might print the schematic later, and if we print it, it'll be helpful to see that on the printout. So I will go here, grab text. I'll again hit tab before I place it, and then the text will say active high.
And generally you can infer this because enable doesn't have a bar over it. However, not everyone who makes a part, makes it perfectly. I don't know if Altium manages the part index manually or if it's auto-generated. Never hurts to double check that what you're placing is correct.
Gonna make some simple changes to the color and size, and then I think I will just throw this right here and we'll move it if need be. Do you know what those caps need to be?
One mic.
And does it matter, do we want tantalum or do we want ceramic?
Ceramic should be fine for this. Actually, let me double check. No, ceramic's fine. Go with 0805 or 1206, or 1206. But again, we're being space conscious.
Right, I'll go 8 to 5. And 1 microfarad.
Try Cercap instead of ceramic cap. Oh,
Looks like I've got them. These will do.
I'm seeing it.
Okay, then we need 2. One thing I like to do for these capacitors, and I don't know if this is technically great practice, but it does make your schematics more readable. Whoa, what happened there? I'll grab both of these at the same time, float them, hit tab, and then I will just block the comment because I don't need to see this big long part number. It doesn't really help me anyways. Occasionally I will change it to the actual value, so I'll write 1UF here instead.
I'd suggest that. Because for generic components, no one cares who makes them.
Right.
And if it is a specialized capacitor, you're going to know the exact part number. I always put the values there. That way you can, easily reference what's what.
And when you go to assemble your board, I'm going to strongly recommend that you print out the schematics and have a paper copy next to you, or at least on an iPad or something while you're working. So you want to see these. You want to unhide those comments if you need those values.
And additionally, I can't speak for Altium, but from what I've seen while I was doing some work for some people, and just generally, often you won't print values of capacitors on your board. I know that might be common when first getting started, but we don't have the space for that. And generally, you want to, make your board efficient and clean, and having to leave room for component value labels will make your routing different. So we'll avoid that here. If that sounds good to you?
Yeah, absolutely.
Cool.
So the next thing is our JST connector. There's a lot of options for this, so let's try and think what is the best one. I think you mentioned a right angle connector.
Yeah, I think that'd be ideal. It'll be the shortest connection.
So there's this one, for example. See if DigiKey has it. It does. That's a right angle.
455 2257.
It is a through hole.
Um,
What do you think?
see if we can find a surface mount.
SMT side entry. That looks like better, but it's out of stock. Make sure before you place the parts that you check if it's in stock by hitting this SPN. You'll see that
Additionally,
this is not.
I know that Adafruit does sell them like in packs of 10, I think. So if we really wanted to, we can always buy it from them, and not buy them from DigiKey. But that's a little sauce. Or just like it's an extra step. And if you're trying to go fast on SGP or something like that, you need to optimize for everything. And shipping is not always easy to have ordered. That takes some time. So what do you think,
Let's
Chris?
do
Should we care?
this. Well, I think I might have found one. I just want to check it on DigiKey to see if it's sufficient.
Okay.
This one right here.
Can you read the number, please?
Yeah, it's a 455-1669-ND.
Thank you.
And this is a good step.
Also through hole?
Oh, you're right. It is through hole. I couldn't see in the picture, which is why we looked it up. We can always put down a through hole one for now, and then if it ends up being a problem, swap it out.
Yeah. And the reason we're looking for a JST connector is I soldering a battery directly to PCB might work, but since we aren't adhering the battery to the PCB, it'll be probably adhered to the case, or rather, we don't know how we're mounting the battery. It's less serviceable. There's also more things to go wrong, and you don't want to, solder a battery since they're temperature sensitive. Oh, we didn't mention on our list, we didn't put a battery. We're going to go with the battery, probably the largest that'll fit, and it should be lithium ion polymer since that's cheap, easy, and well tested.
Sounds good. Did I just find one? I can't really tell. Again, the pictures are so small. No, it's out of stock. All right, let's just go with what we had, and then if we need to swap it out for a smaller
Yep.
part, then we will do the research.
Yeah.
So let's go with this guy.
If you ever know what, if you whenever you don't know what to do something. You can always come back and edit it. It's not final. And having a PCB that's hacked is better than having a PCB that doesn't exist.
Can you comment on the MP1, MP2?
Those should be mount points 1 and mount point 2.
So these are
Generally,
mechanical connections?
yeah. Generally, you'll either leave them alone or ground them.
Okay.
Often, yeah.
Cool.
And before we connect that, we'll want to look up what pin 1 and pin 2 are because there's a standardized connection polarity for JST 2PH connectors for makers, and it's the opposite of what the drone industry uses. We don't want to
Interesting.
plug it in backwards. And again, because we're conserving space and we know we're only using this circuit in one situation, we can do the manual work to check that polarity as opposed to adding protection circuitry. Generally, do add protection circuitry, but we're doing this one in a more casual fashion, not submitting it for a design review.
Absolutely. So the next part is a RTC, and we picked this one out, plus TRL. I feel like I say absolutely so often. All right. Here is...
You absolutely do.
Yeah. Here's a package. Yes, this is our expensive RTC. Is $7 for this chip, but it is worth it in this case.
And it's all in one. We don't need an external crystal or anything, just a bypass cap. And a pull-up for I2C, of course.
I'm going to move right on to the next part, which is our battery charging IC.
Let's throw the pull-ups on while we're there.
Sure.
2 10K, 0402. Or 0603 if you don't want to
Chip
go that small.
Res 0603, and you said 10K?
Yeah.
The reason we care about the size too of some of these passives is because different sizes are standardized to be rated for different wattages. So this is a 1/16 watt resistor in this case. You need to think about that. You cannot, power an LED in all cases off of just any the smallest resistor you find, because you will burn it out.
Same thing for you can't just power it off of a pin on your microcontroller. You'll burn the pin out because internally it doesn't have the right setup. Let's throw a third one on there because I forgot the reset pin probably needs a pull up since it's active low reset.
By the way, another tip I'm going to throw in is just if you have a bunch of passives that have the same value. For example, if I go to put a pull up somewhere over here, maybe on the reset or something, copy and paste this part before it gets its designator instead of looking it up, because if you pick a different part in your manufacturer part search and then you create your BOM, there's a good chance you're going to end up with a DigiKey order that has 3 or 4 different types of the exact same resistor. And if you can avoid that confusion, why wouldn't you?
Actually, yeah, let's throw a resistor over near that reset pin, both of them, the
So you want 3 here?
watch and the 3 there, and then 1 over by there, just so we can be lazy and work quickly.
Works for me.
And again, not lazy design, lazy and working.
Doing less work rather than more work.
Yeah, I guess lazy is the wrong term.
Smart is the right term, right?
One would hope, but we'll see.
So, the other thing is, again, like I said, I'm not putting designators on these. I'm leaving it R question mark, because Altium will do that later, and it will save me a lot of time and prevent me from making mistakes if I try and generate them myself. All right. Battery charging IC, also pretty easy. You pick this one out. Has a model.
This was nice. It only requires 1 resistor for programming, and it has an output for your status. Are we going with the 3-1 or the 3-2?
We picked this one last time we talked, but we don't have to necessarily go with one over the other.
Okay, the 3-1. The 3-1, I think it's open drain. So if we want to read status from there, we'll just need to pull up. But you can also, do other things.
Sounds good.
Throw a resistor there with an unknown value, somewhere between 2 and 10K.
Unknown value.
Yeah, we'll have to go and read the data sheet once we just figure out what size battery we have.
For now, I'll throw one of our 10Ks on there, but we might have to change it later.
Cool.
Up
10K is the value which will give us the lowest charge rate.
And in that case, let me throw this on here, and I will just make a note for myself to review resistor value. Cool. So now, hopefully, won't forget that.
I forgot to mention we need 2 more resistors over near the USB-C port.
Yes, and these are 5.7?
5.1K.
Close. Chip resistor.
Ooh,
5.1K.
I like this connector.
Which one?
The J1, the USB-C one. It looks like it's great for easy use while integrating USB-C.
There is our 5.1s, and if you don't know why we need 5.1s, you should definitely do some Googling and reading about, USB-C, but basically, depending on what type of data or purpose you're using for, in this case, since we're using the USB-C passively, is that correct? We're using the passive...
as a 2.0 port.
Yeah, as a 2.0 port, you'll pull down, I believe it's CC1 and CC2?
Yep, with 5.1K resistors.
And that just says, hey,
don't
CC1
do all your
here.
fancy magic. Oh, does that one have 2 ports? Or does it only have... I'll check the data sheet. Continue with adding other things.
Okay.
Oh no, it has all the rows on the footprint specified by the data sheet. I think this is a good example of, check the things we're using.
Maybe it calls it by a different name.
No, CC2 is on the B side of pins. Are you
Interesting.
does Altium allow for multi-part schematic symbols?
Yes, it does.
Could it have had a second one?
I'm not sure. I don't think I've ever encountered that actually in a manufacturer part search part. Let me see if it has multiple. It does say 24 contacts. Interesting. I could be learning something new today.
We could search for it again and just try to place it again.
Yeah. Maybe we should do that. I wanna.
And again, that's like, could we investigate and figure it out this way? Probably, but it might be faster to just replace. Pun unintended.
I agree. Interesting. Okay, well, let's see. Maybe there's an easier choice where we don't have to worry about this. If someone decides to look into that process and see how to switch to different models, or if manufacturer part searches can have multiple parts, let us know.
Throw it in the comments.
Sure.
We'll star it or something.
Okay. And let me go back to my part search. USB-C connector. So what do we have? We have the wort. That one
Try
was
two down.
expensive. And now we're kind of outside of the range of USB-C. I'm starting to get micro.
I think there's one from TI Connectivity. Yeah, wait, go down. Right there. The Amphenol, sorry.
This one?
Yeah, let's take a look.
Do you want the part number?
DigiKey part number,
They
please.
do not have it on DigiKey. Stock 0.
Oh. Okay. Let's try placing the Molex one again and see if like it requires 2 clicks.
Interesting.
Yeah.
What's that?
Wait. No. Did you hit escape?
Yeah, I canceled placing the part.
Don't cancel it. That's the second section. So that has A's and that has
Oh,
B's.
look at that. I've never seen that before. That's super interesting.
Eagle does it the same way.
Cool. Okay. Well, we fixed the problem. How do I want to organize this? Let me flip this and put it over here. Oh, there's a third one.
And there's your mounting holes. Yep.
Okay, let me
It's
try that again,
4
because I
legs,
canceled it
think.
again. That's super cool.
That's
Okay.
2 parts.
Alright, so I probably want to line these up. These guys are going to get turned vertically. Whoopsies. Okay. Yeah, this is really nice. So Altium will take care of the footprint when we switch over to our PCB design. So we won't have to worry about these being separate things. And actually pretty convenient. So I guess, going forwards, look out for that when you're placing parts. And I'll put these here. Obviously, we're going to connect CC1 and CC2 to ground. Is that right?
Yes, we're pulling them to ground.
Awesome. And we're going to ground the mounting holes too eventually.
Yeah.
All right.
You don't technically have to. But...
Our next part was our right-angled buttons. Yeah, so these are going to be the buttons on the side of the watch that come through the housing so that you can, you know, change the mode or the time or whatever.
These will be interesting. Can you pull up Digi? Oh, no. We're going to use MPS?
Yeah.
Okay.
SMD right angle button. Guess it should be momentary, but I'm guessing that's what we're going to get.
That's what we want.
All right, yeah, plenty of options. It depends how we want to go.
Is there any way to zoom in or no?
I wish there was. There probably is, to be honest. The answer to most questions are like, can you do this in Altium? Is usually yes, somehow.
But
probably yes somehow. The question is, can you find the button to do it? And I just lost that search, so that's great. SMD right angle buttons. Yeah, sometimes in the tutorials we plan them out like ahead of time. What is going on? No, there's nothing. What did I do? I wonder if I could go through this and find some electromechanical. This might be an interesting way to find some buttons. We didn't really find a particular button model ahead of time. We figured it would be pretty easy to just grab one. Famous last words. What throw configuration do we want? Guess that's kind of up to us.
Single pull, single throw, or single pull, dual throw.
There's some single pull ones. Let's do single pull.
And SPST.
SP, do you see that? SPST.
Oh wait, these are switches, not buttons. Oh wait. Oh, I stand corrected.
Mounting case package SMT. That's us. And there should be something to make them right angle in here as well. Hold on. Termination.
SMT.
Doesn't look like there is. Maybe we've got some options in here.
There are some right angles. Let me see if I can find a part number from a board I know has good ones.
I can actually search right angle within these filters and see what we get. So let me scroll to the top. This one looks pretty good. DigiKey have it? What do you think?
They're pretty common.
Yeah.
Yeah, they can be a little weak over time, but I've used those before. Although I'm never good at choosing the right weight. Do you know what a good one would be? Also, the package you suggested is commonly made by multiple manufacturers.
Right.
An unofficial standard kind of thing.
Well, what do you think? Should we go with it for now?
Sure.
I'm good
It's
with
a
it.
button. Shouldn't be hard to switch, right?
I agree.
Pun intended.
That was pretty good. And we want, what do you say, 2 or 3 of them?
2, and then the
2?
reset button will be vertical.
Cool. So let me get rid of... Yeah, the reset button will not be shown through the package necessarily. That might be just on the PCB.
Yeah. Or if we do want a right angle, we should put it sunk in, so you have to poke it with a
Right.
thingy.
Certainly you wouldn't want the user to accidentally reset the microcontroller in their watch. And that can be any one of these. I guess if we're being space conscious, we might choose something like the
Little
first
rubber
one.
one.
A little what?
There are little ones. They have like a little yellow rubber top. Teeny.
Do they look like this? Are they the squarish ones?
No, they're little rectangles. Tiny
Uh,
nib in the center.
why don't you try and find it on DigiKey
Will do.
while I'll grab our. Actually, that's pretty much the last thing we were. There's the optional battery management IC and such, but
Let's see how much space we have.
yeah. So we'll leave it out for now. So yeah, let me know if you find it on DigiKey.
Working on it.
Of course, you don't necessarily have to use DigiKey for your SDP project. We just use DigiKey for most things because it's real easy to set up and use. We have a lot of experience with it, and they stock most parts.
And they'll ship, I think before 9.
Right.
If you put your, they're usually same day shipping.
Right, and they, I believe it comes right out of the U.S., so the shipping doesn't take too long.
Yep, it's either North or South Dakota, I think. Like Mauser has a great selection too, but
yeah, as
they're
opposed to
in
Mauser.
Europe.
I will ground these while we wait. This is the next step. Also might start kind of organizing how these are going to go. Cool. So these buttons are going to be close to the MCU. Let's think here. This is the battery management.
Oh, I found a good alternative to what I was looking for. I've used them before and they are very stable. Ready for the part number?
Oh yeah, sure.
Manufacturer or DigiKey?
Let's do DigiKey.
Okay. E as in Edward, G as in Gary, 5384. T as in Thomas, R as in reload.
That's it?
Yep. Well, dash ND, but
It is here, but it does not have a model.
ooh.
So we could
Okay.
either make our own. What do you think?
Let's try one other. I've also used these. Ready?
Yep.
KMR
KM
731 NG.
731. What was that? NG?
Yep.
Present without model. If you're wondering what the point of having a product that is present without a model, really that's Altium keeping track of the bill of materials for your project. So you could place this part and kind of use it and then provide your own schematic symbol and footprint for it. And then when you went to generate the bill of materials at the end, it would include the part and it would know, what, where to get it from and how much it costs. But yeah, you would be required to make it on your own. I think let's do one more time. Just look through SMD momentary buttons and just see, because it's not
Try
like.
switch tactile.
Yeah, that's true.
That's keywords.
Switch tactile. Right, because we could use one of these or something. I think there's probably enough space to throw one of these. These really flat ones too.
That KMR is what I'm looking for. That was the second one that was suggested. I
Which
think
one?
it's just a different weight. Third one down.
This one? Alright, let's use it. Looks good in stock, 48 cents. And we'll put it here. Okay, so now let's kind of organize this. We are going to have to make the part for the screen. We'll get there. Cool. Okay, so this is MCU stuff, I think, right here. Let's try.
Well, the buttons aren't, but
well, they're going to connect to the MCU, right?
yeah.
So let's give that the bottom left of the schematic. Let me put these over here for now. That way the top left can be USBC stuff. I think this will work. I guess these buttons are going to go... well, I guess it doesn't matter too much. Depends
Well,
where
the
if
reset
we're
button
putting in...
should go near the reset.
Yeah, I guess let's use those ports first. The ones on the left. So I might push this over here and then grab these. This matters more than you might think it does.
Is it
Laying
difficult
these
to
out.
go back and forth between board and schematic in Altium?
Not at all. And actually you can have them both on the screen at the same time if you want.
Okay. Because we could, in theory, wait to choose what I/O pins we use until we know where we place the buttons.
Yep, absolutely. We could import all of these footprints to the schematic right now without any connections. Wouldn't necessarily, I think, be the easiest or greatest thing to do, at least without some of the basic connections, but yeah, we can definitely do that and see what we're working with. So maybe we will.
Let's just focus on power for now. We can do routing and placement screen stuff next time.
Good idea. This is our battery management right here. Put that there. I want to put headers on the or text on these so that I kind of know what they do. So I want to make sure I leave room for that.
Do you ever do the little boxes to separate sections of your schematic?
Yeah, I can make those. This was our... Do you think this
Between...
JST connector is going to be close to the MOSFET?
Yes. It'll need to be close to the MOSFET, and I guess we can use a name to bring it to the DS3231. Sorry, the RTC.
Sure. Okay.
Because the RTC has battery backup features.
By the way, shortcut V and then D to fit what you're looking at to the screen. So V then D maximizes the space on the screen. Okay. And then I will hit tab so that I can set the precedent for the header text. So I think all of our header text, well, let's just write the text here. So this is going to be the USB-C connections. Oh. And we'll make it black text with 18, maybe. Yeah, we'll do 18. Put it in the middle. Cool. Now this is going to be the MCU. And I'm going to write at SAMD51 right there. What do we have here? What is this? This is our battery charging IC.
What are you looking at?
No, it is not. This is the RTC. My bad. This is the voltage regulator. This is the battery charging.
Yes.
And then this is, what are we going to call this section here? The power select input V in select. I don't know.
We can just glob it in with a USB-C circuit and just call it power in.
If we're going to combine it, then let me make the text a little smaller. So it's like a sub header. And you want to throw it into USB-C.
Yeah.
So I think it makes sense.
There's one thing we forgot.
What's that?
We should add a voltage divider so that we can measure the battery.
Good idea.
That's just 2 more resistors, and we can. And of course, if you're doing an actual thing where you want battery percentage, use current measuring. But again, this is quick, and it's not meant to be an exhaustive, proper thing, right?
Right. That would be on the STP teams to design the perfect watch if that is your project. So we want a voltage divider. Do we know what values we're going to choose? What do we need for the range of that?
Doesn't really matter. Actually, no, it does. Let me pull up my personal watch project for the values.
Yes, we have the benefit that Jay has actually designed a watch before. An actually good one, too, so.
Well, it's still a little buggy, so we'll see. Okay, so for my video, since we know that the battery range is going to be between 4.2 and 3.7, we want to scale 4.2 to be 3.3 volts, which is 270K on the top, 330K on the bottom, or 2.7 to 3.3.
Chip resistor 0603.
And if you're having a bunch of issues with measuring this value, I would go with lowering the values but keeping the ratio, and that should reduce the noise a little bit.
Whoa. All kinds of glitches. This is our 270K. And what was the other one?
330.
$330. Cool. All right. Looks good. We have space in case we want to add our accelerometer or whatever we're going to do later. For sure. So
Yeah.
what time is it? Should we start wiring
we'll
this
have
up
to
a
see
little
if
bit?
we have physical space. Yeah, we have a couple minutes left.
Cool. Let's start with the USB-C. So I did ground CC1 and CC2. I grounded the mounting holes, which is basically the rest of the case. And now there's those pins on the inside, which we don't need all of. Obviously, we're going to ground the grounds.
And we should link all the V buses to V buses. As idiotic as that sounds loud. Wait, no, don't, not that.
I don't want to ground.
No, you connected ground to CC1. I'd throw a
you are
second ground
correct.
symbol up there.
Yes, you are correct. So let's do this to make this a little easier to read. I will delete that. I will grab this. I'll hit space to rotate it. And then I will put it there. And now it's a little more idiot proof, as is necessary when I'm working on it. Whoops, I always grab the comment instead of the part. My laptop I think is slow because it's recording OBS and running Discord share screen and running Altium. It's like 7 years old, so I kind of feel a little bad.
Sorry, it's that time of night. My English is breaking down. The V buses.
Yep.
Do
Let's give them a
names for
net.
those, or... Okay.
Just stick a net on them. And let's align it to the left. Let's call this V. What? V bus is fine.
V bus or V bus raw. Let's go with V bus.
V bus, V bus, V bus. All 4 of those. And now I'm going to select all of them, and just good little tip is to, once you make these connections, drag them out a little bit. That way there is no ambiguity over whether or not VBus is connected to the rest of the, to the actual component, because you can see the actual wire there in blue. You don't have to wonder, is that actually connected or not? Okay.
Let's add labels to D- and D+ then.
Okay.
Since we're gonna allow... Since we're gonna flash a bootloader that's stock, well, not stock, but easy to make, easy to use.
Here's D+. select these, do the same thing, move them over. If you're floating some parts, you can use the arrow keys to move them if you're trying to make it very consistent, which can look nice. Okay, and the rest of these I think we will leave floating. Yeah?
Yes, that is, yeah.
Cool. I'm gonna hit save. Actually, let me move this over so that it looks nice. It's not just about making the schematic look nice. Spending time making sure things are actually aligned is going to be valuable when it comes to looking over the schematic later and getting a good idea. There's a big difference between a hastily compiled schematic and a schematic that someone takes time with and organizes properly. So let's do our reset circuit. So we're going to...
We're also going to need a cap for that.
For reset?
Yes, we will want a 1 microfarad cap.
Okay, ceramic cap. 1 UF. We've been using the 0603s, so let's just keep on with it. And actually, don't we have one of these before? Or did we use a point?
Yeah. No. On the...
Yes, that's right.
Yeah. Well, the battery IC will need caps too. I think 1 mic each as well. I'll check.
Okay, let me copy this and put it over here, as I mentioned before. So, cool. Yeah, so this is going to be our pull-up. Well, we got to think, because what is going to supply the voltage? That's going to be
4.7
4.7 on
for the battery IC.
Battery IC. Let me do that now while we still have it up. 4.7 microfarads. Looks good. Place. Tab. And this is 4.7. Cool. Alright. So we got to think, because the 5 volt supply, or no, 3.3 volt supply for our microcontroller is going to be coming out of something else. Is it going to be coming out of the regulator directly, or is it going to be coming through, because we're doing this thing with the circuit here?
The 3.3 volts will be coming out of... What was your question?
Do I want to directly tie the supply for the microcontroller and the rest of the components to the output of the 3.3 volt regulator?
Yes. So actually we should put the regulator on the right side of that power shenanigans.
Right.
Because we're going to use the power shenanigans to switch.
Right, those feed into that.
The bus.
That's what I wanted to make sure of. Cool.
And I say, after hooking that up, shall we save the rest for next week?
Sure. Next week, next episode. I don't know when you want to record
next
again.
episode. Yeah, you know what I mean.
So let's do that. Let's grab a net. If this process seems like it's long and tedious, it absolutely is. And it should, that's what you want. You want to take your time with it. I think I might use one of the nice symbols for this. So I can say, like, place +5 power port, like that. And if I hit tab, I can actually change it to 3v3, which is the standard I like. You can use 3.3 volts if you want to use more letters than is necessary. That is your right.
Do you need the plus?
Okay, you got me. Don't technically need the plus. And then I can grab it and copy it. I could also do the V bus as those symbols too. I don't know. What do you think?
Is it easy to switch between them?
Doesn't really matter.
Yeah.
For at least this project. So there's that, and then I want my ground to go from here, so I can. Do you usually tie these like 3 and 4 things together? I've done that before. Not technically necessary.
I do. Yeah. Won't hurt.
Won't hurt. And then this will go to ground. And where does that cap fit into the equation?
It goes between reset and ground. It's a debounce cap.
Right.
Is it really 1 microfarad? I don't believe that. Let me check my.
Worth a double check.
Yeah, because that's huge for what that is. I bet it's 0.1 microfarad, and I'm having a I issue. I'll download the schematic. But while waiting for that,
Let me find a 0.1 just in case.
nope, the reference board is a 1 microfarad cap.
All right. Well, that's fine.
Okay.
Shouldn't kill anybody. And this can also go to ground. I think I will just use this
At the
ground
most,
symbol.
it'll burn their wrist.
Okay.
Coolio.
Yeah, the user accepts all risk from wearing the watch.
We can put that on the boot up screen.
Sign the waiver to get the time. Okay. Cool. All right. So yeah, there's a little more to do in the schematic, and then we can start laying out our PCB and making decisions about how the layout's going to look, which will actually inform, like we mentioned, we'll go back to the schematic. We will decide where these buttons make sense to go, so that the routing for them is as easy as possible. We have to talk about how we're going to program this. We have to make a symbol for the screen. So there's plenty more to do.
Yeah, we also need to make a symbol for however we're going to connect that programming.
Yep, that's true. We can use a symbol for that. We could also use the default parts if it's going to be just like a ICSP or a, I don't know.
Although,
We will talk and decide.
Yeah. Thank you.
Cool. All right.
Okay. We'll
Awesome.
see you all next time.
See you next time. And any questions, post them below.